All right, calculus, we're on Unit 1, Day 6, and we're going to just continue with our practice for limits. So we are looking at a function, again like yesterday, and we're looking as that x value approaches -1. Sometimes it can be helpful to have a look at a function to kind of get an idea. So I did this one on Desmos, and we're looking at this funky thing here with an asymptote at, let me look. I don't know, it's ugly. A negative decimal something or other. So I have got this function that was, and does this. Okay, just so we have the idea. And we're looking at this function as you're approaching a value of -1, and it certainly appears from a graph that it is approaching a value at that place. But to do it formally algebraically, we're going to see if we have an indeterminate there. So if I substitute in my head -1 directly, do I get a 0/0 problem, or do I actually have a value here? So the first thing we're going to try is direct substitution. Okay. So if I put -1 in there, I have a 1. Subtract 5 times -1 is +5, plus 2 is 8. We do not have a 0/0 problem. 2 times -1 cubed, -2, subtract 3, -5 plus 1 is -4. So this does approach a value of -2, just as we thought from looking at the curve. It is approaching that same value of -2 coming from the left and coming from the right. Direct substitution worked in that case. Let's look at this second one. So looking at the second function, I do find a graph can be helpful, so I also have that on Desmos, and I have a function that looks like that. So just a rough sketch here. I have, nope, that's a little steep, but anyways, you get the idea. Okay, something like that. So we don't know if as x approaches 5, do I have 0/0? No, I do not. So I'm going to try a direct substitution. Okay, so my limit, if I put 5 directly in, is 25/4, which is 5/2 or 2.5. So that function, as we are approaching the value of 5 from the left and from the right, is going to be approaching a value of 2.5. All right, the last one. If I do a direct substitution for this one, I'm going to get 0/0. So I have an indeterminate. Let's have a look at that thing for a second. All right, let's have a look at that. Graphing calculators are fine too. We have a function that looks like that. If I can zoom in. Zooming in didn't go so well, but I do know that there is a problem when x equals 0. So I have a function that looks like that. Technically, it's just not showing really well on my technology. So this is my function. Where x approaches 0, I know that there's a problem. So all of that 0/0 is indeterminate. It doesn't tell me, is there a limit? I don't know. I mean, I'm looking at the picture and I think so. But 0/0 doesn't help at all. So we're going to use our skills to try and determine that. So as I look at this thing, I'm thinking expanding, factoring, common denominator, or rationalizing. So with the rational there, I want to multiply by the conjugate. So root of x plus 1, subtract 1 over x. I'm going to multiply that by root of x plus 1 plus 1, root of x plus 1 plus 1. Okay. Limit as x approaches 0. You keep writing that until you actually put a 0 into the function. Just for clarity, we are multiplying, so it's like FOIL. You end up with x plus 1. Outside inside disappears. Negative 1 over x times ugly. Okay. The top nicely tidies up. The ones cancel. Plus 1 subtract 1, I end up with x over, wait for it, x, yay! So I have gotten rid of my 0 over 0 problem when I divide out x from top to bottom. So now I can do that direct substitution and put the 0 in. The limit as x approaches 0 would be 1 over. Square root of 1 is 1. 1 plus 1 is 2. It's a half. So that value, as you come from the left and from the right, is approaching the same thing, and it's approaching a value of 1/2.